Hey there, IT 140 students. So in this recording, we're going to introduce classes and objects out of Chapter 8. So let's take it from the beginning here. So they're saying that a large program thought of as thousands of variables and functions would be very difficult to understand. So for instance, let's say that we are creating a program for a car race. And we might have all these different variables. So race car, one, it has an engine, right? And race car one has an alternator. I'm just thinking of car parts. And race car one has a steering wheel. So if we wanted to create a different car, we would potentially do something like this where we copy everything, we paste everything, and instead of race car one, we call it race car two. And so anytime that we duplicate efforts like this. So if I've got variables that are representing two different race cars this way, this would be very difficult to maintain, okay? So what the idea here that we want to have is how can we encapsulate the information about something, and then without having to copy and paste, I can create references from it. So the idea goes like this. How can you take from in the physical world where we have physical objects, things that we can actually touch and see, and then transfer them into kind of a more abstract idea? So again, the idea I have here is that I know that a race car has an engine, has an alternator, has a steering wheel, and has all sorts of parts, tires, fuel cell, all those different things. I know that that race car has that. What we want to do is not only encapsulate some of its internal data, but also operations that can be performed with that data. So, we know that a race car has got an engine. What are some things we might want to make the race car do because it has an engine? You know, go fast. So we use the engine to make it move. We've got an alternator that makes sure that the charging system, the electrical system's working. The steering wheel is going to provide us a way to go left and right. So we have fields, we have things that the object contains, and then we're going to provide methods that they work with. So they give us a couple examples here. So a runner, I'm a former distance runner, former coach. This is perfect. What are some things that runner info might contain? Well, it might contain how far they went and how fast they did it. So we've got their miles, we have the time run in minutes. Things that we can do with that data is I could calculate their speed. We could print some runner stats if we so choose. Another example, we've got crowd info. So maybe this is for some kind of event. How many spectators were there? What's the ticket price, normal ticket price? How many students were there? What's the ticket price for a student? And then how do we calculate the revenue of this information based on how many spectators, the ticket prices, number of students, and so forth. So what we're going to try to do is identify what the object has and then methods that work with that particular data. So again, they introduced the idea of an object here. So in 8.2, they continue talking about the idea that classes group data together. So anytime you have multiple variables that are frequently closely related, we should create a class that's going to encapsulate all of that information. So let's scroll down here. So they're going to create a class called time. So you can see to declare a class, this is going to use the keyword class. The name of the class, always uppercased to start with. So this is not lowercase, always uppercase. And then inside this init, this initializer method, it's got two underscores before, two underscores after, and it has the self keyword. This self keyword refers to myself. So I am an independent time object, and I can create multiple instances of this. Continuing on, the definition of a class begins with its class header here, and then inside the initializer, we provide it the fields that it has right here. So a time has an hours and minutes. We could extend it if we wanted to have seconds, but for now, this is fine right here. So it's got hours and minutes. You can see that they are initializing them and setting them to default values of 0 here. So every time you create a time, it's going to start with 0 hours and 0 minutes. So here's creating that class. Here is using that class. So we're going to create a variable that is of a time type. So you've been creating variables all term long. You might have something like my int equals 5, my string equals, in quotations, a word, Eddie, whatever it is. So now we're learning how to create specific types, and then we go create a variable equals, and then you use the name of the class with open and close parentheses. So now we have what's called a time reference object here, and we can access the attributes of the object using the dot operator. So I go my time dot, I'll see hours, I'll see minutes, and I can set them as I want to. So this is to assign values to them. We can also use them to display output or check values of it. So you can see here that they're going to set it to 7:15 and then they're going to print it. So let's just see this all in action right here. So let's delete that. And again, I want you to see here the power of IntelliSense. So I've got my variable, my time. When I hit the dot operator, I'm going to see hours and minutes. Those are the things that I've given available to it. So if I tried to do something like my time dot seconds, I don't have any seconds. So when I run this, I'm going to get an error saying that the object has no attribute seconds because I didn't provide it. So my time dot hours equals 7. Likewise, again, just for demonstration purposes, I hit the dot operator and I can find the minutes right there. So now when I run this, it's going to have hours 7, minutes 15. Great, and it printed it out. Oh, by the way, let's run this with the debugger. So I'm going to put a breakpoint right here, debug. So let's step over one time. So my time, if I expand it down here, and I can see that the hours are 0 and the minutes are 0. That's because when I create a new reference, it starts out with zeros and zeros. I'll step over. This set the hours to be 7. So we see that right here. If I hover over my time, I can expand it here as well. So the hours are 7, minutes are 0. And again, I step over one more time. Now the minutes of that object are 15. Hours 7, minutes 15, and it is functioning as I intended it to. And this is just showing so we can create multiple instances of a time object. So let's come in here and copy this. So they're going to create time 2. So I've got my time up there, and I'm just going to go time 2 right there. And so we'll copy this, and instead of my time, we need to change that to be time 2. Remember, anytime you copy and paste code, make sure that whatever needs to be updated gets updated. So now I'm going to move my breakpoint down to here. So now we're going to have a different time instance. So I have a reference to something called my time. In fact, I want you to kind of take a look here. This is telling me what the memory address of that storage location is. And I can see it's got something like 7520 on the end. Let me step over. Time 2 is going to be a different memory location. Look, it does not end in 7520. So again, when I have this variable, I can kind of see the memory location. I know for sure that these are two different memory locations or two different memory objects. Again, time 2 starts out with time of 0 and 0. Let me get that to expand. There it is. So hours and minutes are 0 and 0, but then we're going to set them to 12:45. So now I can see my time 2, hours, 12, minutes 45. So I got two different memory locations, one for 7:15, one for 12:45, and I have encapsulated two different sets of information. Okay. So again, the big idea with these objects, these classes, is we want to encapsulate the information that this contains. Okay, so in section 3, we've seen how we can have attributes of the object. Well, we can also provide it methods that provide interaction with it. So here they're going to create a real simple method called print time, and this needs to be including the self keyword. And so what this does is it says I can be called by any time object. So I create a time object, I set its hours, I set its minutes, and then I can call that method right here. So I'm going to copy this part right here, and I'm going to paste it in. And so now this method print time is a member of the class, and I don't need this right here. So now I create my time object, I set its hours, set its minutes, and then print time. What's going to happen is it's going to call the statements that are contained inside this method. So when I run this, watch this, I'll put a breakpoint when I run this. I'm going to do a this steps into any methods that I come across. And so look, check it out. It jumped up to the definition of what print time has. And so now I'm going to print the hours, print the minutes, and it is functioning as intended. Now, a mistake that new programmers make is that they'll define this method called print time, and you can already see that there's a syntax error here. If I want this method, I need to have a parameter called self. It is a Python notation that's required to make this so that it is a function available to every object of a time reference. They point out that the initializer method, the init, is a special method we'll talk about here in a second. It's a constructor. Python usually uses 2 underscores before and after to kind of represent methods that are special to a class. So avoid using those in your notations. If somebody comes across it, they're going to think that you've overridden, that you've done something to a method that is a Python method. Don't do that. Always make sure your method names are conventional. So for instance, they've got an employee, has a wage and hours worked. They're going to provide a calculate pay method, and they don't have any underscores before, no underscores after. Keep it just like all the methods you've been creating all term long, where you would call it calculate underscore pay. And oh, by the way, they're pointing out what I just pointed out, that if you do not have the self keyword in here, that this is not going to run in the interpreter. It's going to crash out. So you have to put the self keyword in there for it to run. Okay, so let's jump ahead to section 4 here. So here they talk about how we can add what's called a class attribute. And this is something that's shared amongst all instances of that class. So for instance, they have a class called Marathon Runner. So I'm just going to copy and paste all this code right here. So a marathon runner runs a distance of 42.195 kilometers. By placing this as a field not inside the initializer, every marathon runner has access to this method right here. So you can see down here, I can access it using the name of the class, or I can create objects of marathon runner type, and I can pull those values as well. So when I run this, it's going to print out, let me just do this real quick so I can get this to compile. We can just type pass, pass, and so run. So now you can see that it is calling that value and displaying it out for us. Now, oh, by the way, the race distance, if I try to set it, so if I go, let's do this, marathon runner dot race distance equals, let's just change it to something different, 500. So now when I run it initially, it's going to start out as 42.195, but look, I changed it, and everything else that references it now gets the new value. So be very careful with this. Uh, in other programming languages, you can guard this value. In Python, you can't guard it. Anybody has access to it, and they can change it. So that's what they are demonstrating right here. I just did the exact same thing. Okay, so in section 6, they introduced the idea of what's called a constructor. So the initializer method, this init method that's defined in Python, can not only have the self parameter, which it has to have, but it can take values that are used when the object is created. So for instance, when I create a race time object, I would need to know when the time when it started, the time when it ended, and then how far they went. And then inside the initializer, I'm going to set those values. So it's going to look something like this. I'm going to set self.startTime equal to the start time that came in. Self.endTime equals the end time that's coming in. So think of this is just like parameter values to a method. Self.distance equals the distance that came in, and it's complaining because I don't have it indented. So nice little shortcut. I can highlight it all, hit tab, and now it is indented. So now I can create two objects. So now I have two different time objects that are going to have a field for the start time, end time, and distance that have been assigned the values that I passed into it. Remember before, we had values like 0. So I created that time class. It had hours of 0, minutes of 0. Now we can customize every object, and they're going to contain their own values. So when we run this, so I can see time Bobby has 3:15 and, excuse me, Bobby has 3:15 and 6:30 right there. Started at 3:15, ended at 6:30. And time Jason started at 3:15, ended at 7:45. Right there they are. Okay, so they have their own exact times for their values. They take it a step further. Not only do they add, so we could have the start hours, start minutes, end hours, end minutes. Other things that we can have inside of our classes, we could have all sorts of methods. So for a race time, it makes sense that we're going to print the time. So you can see they've got code in here to determine the amount of time that it took to complete the race. They're going to determine the pace. So at some point, they're going to take the total minutes divided by the distance. And then I come down here, I create my race time object, and we can print the time, print the pace. Again, those are methods that are available right here. Oh, by the way, we can provide default values. A preferred way, instead of just putting in zeros inside the initializer method, is to default them as the parameters inside the constructor call. So for instance, when I have an employee, we're going to set their wage. They're going to make a cheap $8.25 an hour, and then we're going to default their hours to be 20. Just like with methods, that if you provided a default value, once you provide one, each new parameter after has to have a value. Otherwise, it's not going to work properly. So you can see down here, they're going to create an employee called Todd. All they're going to do is pass the name. So you have to pass a name, but I don't have to pass the wage and hours. Those are going to default to be 8.25 and 20 hours. Same thing with Jason. Don't pass in anything other than the name, so they get a default 8.25 and 20 hours. But then when I create Trisha, I pass in the wage and I pass in the hours. So that's going to look something like this. So let's just go ahead and copy and paste this in here. All right, so fantastic. In fact, I don't even need to use the wage equals here. If I hover over this, it's going to maybe give me some telesense. I don't have it turned on, but I know that I have to pass in the name, the wage, and the hours. Name, wage, and hours. And oh, by the way, some new programmers get confused. Remember, when you define the constructor in Python, you have to have the self keyword, but you don't pass that down here. That's not a parameter that gets passed in, okay? All right, so let's take a look here. Let's see what we get when we run this. So I've got Todd has 8 1/4, 20 hours. There's their name. Jason, 8 1/4, 20 hours. And then Trisha, 12.50 per hour, 40 hours a week, all looking good. And then, oh, by the way, take a look at this. You can create a list of these employees. So now I have a list of employees. If I expand it, check it out. This is employee, 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 and I can see that it's Todd, 8, 25, and 20. So just like a list of strings, lists of integers, you can have a list of custom data types. And then just like before, I can loop through them. What you have to understand is that this loop control variable right here, it is an employee object. And so let me expand that. It's an employee. It has a name, a wage, and an hours, and they're going to display out their name and what they make right here. So very powerful programming construct. Okay, last section we're going to take a look at here in this recording is providing some other special methods that we might want to have many times. So for instance, we're going to create a toy, has a name, has a price, has a minimum age of usage, and then I want to print out the details about it. So when we run this code right here, so when I run this print truck, all it's going to do is it prints out the name of the class and then some kind of hexadecimal code, probably the memory address. Well, we'd like to get some more meaningful information. So here, they're going to add a string method. And remember, because it has the underscores out in front, this is a built-in method available to all objects. So now when I run this, it's going to return out and print, it's going to return a string of the name, price, and minimum age. So run this. Maybe I'll run this, try to run it. And what is print truck? Oh, I have it defined inside the constructor. Let's pull that back. So highlight it, and if I hit Shift Tab, now it pulls it back. So now it is a member function. So now when I run it, there we go, monster truck, name of it, costs only, the price, and not for children under the age of 5. So anytime I create a class, not only should I provide a constructor, but we should also provide a string operation as well. Scrolling down, they also mention that we can overload some very popularly used operators. Things like less than, greater than, equal operators. Maybe add, subtract, multiply. Doesn't really make any sense to multiply things, but maybe you might be adding some things together. And if I scroll down here, we can override the less than method, the equals method, and so forth. So a very popular one that should be implemented is the equals method. So define equals, and it will fill it in for me. So this time you can see that it passed in not only self, but also other. This is going to be another toy reference that we want to compare against. So in here, we would provide a check of whether or not these two objects are the same. So we might do something like this: self.name is equal to other.name. So we would say if they are equal by using that right there. So let's see if we make this work. Truck2 equals toy. We'll just call it monster truck. We won't put the XX on there. 20 bucks. Minimum age is 10 for this one, whatever. And so if truck equals truck2, then print equal. Otherwise, we'll print not equal. So cross your fingers. Our equals method checks that their names are the same, so these should have different names, so we should get not equal. So we're going to run that. Great, got not equal right there. Let's make it so that they have the same name. And we can see that it is saying equal right there. So most of the time, when you create a class, not only do you provide a constructor, but you also provide a toString method and then also an equals method. Okay, last little bit of comments right here. Anytime you create a method, you should provide the documentation. You can use the triple quotes. It'll fill in, check this out, it filled in the parameter names for me, just like the expectation for our methods. So this is the constructor, name of toy, price of toy, minimum age expected. We can provide, again, a comment for the string method as well as the equals method. All right, so that's going to do it. As always, if you have questions, don't hesitate to reach out.